In this question, we'll construct a linear regression model. The question says an instructor wants to show students there is a linear correlation between the number of hours they spend online and their scores on a test taken the following Monday. Now we have a list of hours and a list of scores. The number of hours spent online corresponds to the score. We'll label the hours with the letter X and the scores with the letter Y. Now to construct the regression, we'll select our X's and Y's, leaving out the headings at the top. We'll say Insert, go to the Chart section, and go to the last graph. This says Insert, Scatter, or Bubble Chart. We click the little arrow by the icon, and the first option will be fine here. Now in order to find the regression line, we'll right-click on one of the dots and say Add Trend Line. Now this displays a number of options. We need to select Linear underneath the first menu, the Trend Line options. Then we can tell Excel to display the equation and display the R-squared value. So a least squares regression line will have the letter Y equals a number times X. This number is called the slope, or rate of change. The number that comes after the X, the plus 93.97, is called the intercept. Now we are asked to find this line and the R-squared value, and Excel gives us both of these automatically. To interpret the slope, we can write a sentence that looks like this. To interpret the slope in terms of the problem, we can write a sentence that looks similar to this. For every X, the Y will change. What we're going to say is that it changes by this amount of the number next to X. We'll say negative 4.0674. Now we'll modify this sentence. We're going to replace this X and Y I've written with the meanings of X and Y. Now remember that the X is the number of hours that were spent studying, and Y is the score. So now we rewrite the sentence, and we say for every hour spent online, now the X is the number of hours spent online, and the Y is the score. So we'll rewrite the sentence in those terms. So we'll start by saying, for every hour spent online, the score on the test will change by negative 4.0674. Now for part D, we can make a prediction for all of the X values based on the equation that Excel gave us. We'll make a new column. We'll title it Prediction. At the top, we'll refer to the prediction as Y hat. Now underneath the prediction, we'll enter the equation Excel gave us. We'll begin it with equals. We'll enter negative 4.0674 times X. We can't actually type the letter X though. We'll need to click on the box in row 16 underneath the X. Then we'll say plus 93.97 to finish the equation. It should look very similar to what Excel gives you in the chart. We now have a prediction for our first X value. We can use the black cross to complete our list of predictions. Now we have predictions for all of the X's. Now to find the residuals, we can make one more column and title it Residuals. Now for the residuals, we take Y hat and subtract Y. So we'll say equals y hat minus y. Make sure you stay in row 16 for our first residual. Press enter. Click on the number we just made and use the black cross. This gives us a list of residuals. Now it's also possible to make a residual plot as well. In order to make the residual plot, what we'll do is select all of our x values with the white plus sign. Hold down the control key on your keyboard and select the residuals. Then go back to Insert, make a new scatter chart with the first option. Now the question asks us to look at the scatter plot with the trend line, the R-squared, and the residual plot. Now for the scatter plot, we want to compare the trend line against the points that we started with. We want to make sure that the trend line matches up with the points fairly well. We can see most of the points are fairly close to the trend line. Some of them are further away than others, but most of them are in the same general area. So that means this trend line is a decent fit for these points. Now we can also look at the R-squared value. Now, the higher this R-squared value, the better fit you have. Now, if we examine our R-squared value, we have an R-squared of 0.6911. Now, the highest you can have for R-squared is exactly 1. And the lowest you can have is 0. So ours is 0.69. Now that's, again, not a perfect fit, but it's a fairly good one. So it matches up with what we've already seen from the scatter plot. We are also asked about a residual plot. To this, we look to our other table that plots the residuals against the x values. Now we can see most of the dots are within 5 to 10 of 0. This is good because we want most of our residuals to be near 0. Now the closer these residuals are to 0, the more reliable our trend line is, and the better fit for the data it is. We can see that most of our dots are within 5 to 10, but there are a few dots that are further away than 10. So most of our data points are a decent enough match for the trend line. But some of the points aren't quite. You may also be asked about correlation coefficient. To find this, we would take plus or minus square root of the R-squared that we found earlier. We use positive if the slope is positive. And if we have a negative slope, we would use a negative R. This is why I say plus or minus. Now, our R-squared value was 0.6911. Therefore, our R value will equal square root of that number. So we'll select it with Excel, close the parentheses, and we get 0.83132. However, our slope was negative 4.0674, so we'll say R equals negative 0.83132. Now, if R is greater than 0.7, we say it is a strong correlation. And if R is between 0.3 and 0.7, we say it's a moderate correlation. And if our R is less than 0.3, we say that's a weak correlation. Now, our R value is 0.83132. Don't worry about the sign when you're trying to decide whether it's strong, moderate, or weak. Now, since our R is greater than 0.7, we would say that this is a strong correlation. And so we'll say that the hours spent online and the score on the test have a strong negative correlation. I'll say negative because of this negative sign next to R.